Hello, I'm Craig Macmillan. I am Technical Program Manager with Vineyard Team, and we are here today at Pleasant Ridge Vineyard in San Miguel, California, where we are having a tailgate meeting about irrigation maintenance. Our speakers will be Jacob Hernandez of JH Ag Consulting and Ben Burgoa of the Resource Conservation District of Monterey.
We are here today to talk mainly about distribution uniformity. The Vineyard Team and I have been working with them on a number of uniformity projects or evaluations around the county, Santa Barbara, Monterey, as part of a DWR research project. So we have worked with a number of you guys. I recognize a lot of you, but we are mainly here to talk about the DU evaluation process, ways to maintain a high DU, and kind of just using this system as an example. We'll talk about different things out there.
Okay, Jacob, I need a short version. Jacob está aquí trabajando con el productor para determinar la uniformidad del riego. La idea, ellos tienen un grant del Departamento de Recursos del Agua del Estado para trabajar con los productores a determinar qué tan uniforme es el riego. Vamos a hablar de las diferentes partes del riego, comenzando desde la bomba hasta el sistema de riego, para entender cómo todas las partes funcionan juntas. O sea que, otra vez, si tienen alguna pregunta.
The place we want to start is at the pump. Whenever we have a problem or anything, the best thing to do is go to the pump and see where the issues are at. And when I come to evaluate your field, what I'm going to do is go right to the pump and look at pressures at the pump and see what's going on. So just starting at the pump itself, where Craig's at, we got the pump and the VFD. The VFD is not essential for distribution uniformity, but it's really going to give you some good efficiency if you install one of those.
Okay, vamos a comenzar en la bomba, que lo que necesitamos saber en la bomba es cuánta presión tenemos. ¿Ves? Hay los relojes para determinar la presión. Al lado de él es el VFD o el de frecuencia variable. Ese controla la velocidad de la bomba. ¿Cuántos de ustedes tienen VFDs en la finca? How many of you have a VFD? Okay. ¿Les da pena? Okay, listo, muy bien. Okay.
Yeah, so the reason why we want to use a VFD, and a good reason why it works maybe in a field like this is when we have different size irrigation sets, we can control the pressure to the set that we want to hit. So instead of running full open to hit that farthest part of the point or the vineyard and having that be the same pressure up here, we can actually adjust the pressure to optimize and save energy for each set.
Okay. El uso del VFD es para controlar la presión o la velocidad en la bomba. Entre más presión podemos poner más velocidad para mantener la presión. Como en este caso hay unas partes bajas y unas partes altas, y y también hay diferentes tamaños de bloques. Cuando hay bloques pequeños, uno utiliza menos velocidad porque tienes que poner menos agua, y comienzas a abrir más bloques, necesita más agua. El VFD ayuda a aumentar la presión, aumentar la cantidad de agua que se le está dando al cultivo.
And so what the VFD is doing is it's got a pressure sensor on that main line at the pump discharge, and it is looking at the pressure coming out of the pump, and it's throttling the power of the motor up and down to kind of, there's some magic to it that I'm not familiar with. Ben's the engineer. He could probably help us out a lot more on that.
Okay, I'll just do it in English. So the VFD is really controlling a set pressure. Depending on how many blocks you have, the flow rate will change, and the VFD is looking at the pressure. So they're trying to maintain a constant pressure throughout the run. So if you open more blocks, your pressure goes down, the pumps accelerate to give you the pressure. But you need to remember that the maximum pressure is given by the pump. So you cannot be open more blocks thinking that the pump is going to give you more pressure. It gets a limit. And the BFD is going to get to that limit and stop. En verdad, el BFD ayuda a mantener una presión constante en el sistema. Como ustedes saben, cuando no había un BFD, si había mucha presión, ¿qué se cerraba? Las válvulas. Ahora el BFD hace el trabajo de las válvulas. Él tiene un medidor de presión en el sistema y mantiene la presión a ese punto. Si ustedes abren más válvulas, la bomba pone más velocidad para darle el agua y la presión que ustedes requieren. Pero acuérdense que el BFD no le da más presión que lo que la bomba da. O sea que si ustedes abren muchos más bloques, el BFD no le va a poder dar más. Hay un máximo que es controlado por el tamaño de la bomba.
Moving on to the sulfuric acid over here. There's a couple of main reasons why guys are going to use sulfuric acid. That could be a pH problem. So if we have high pH and we want to bring pH down to to your 7, 6.5 that you're looking for, then you could use pH injections for that. We also are going to use those for cleaning out the lines.
La siguiente parte es el ácido sulfúrico. El ácido sulfúrico se utiliza para reducir el pH del agua. Algunos de ustedes pueden ver que en los sistemas de riego hay un polvito blanco. Esos son los carbonatos. La idea es que al poner el ácido, esos carbonatos se mantienen en solución y no afectan que se les taponen los goteros. Gracias.
Something else that acid is going to be effective for is breaking down those precipitates and stuff in the line, the junk in your line that is going to clog emitters or clog the ends of hoses. So that's going to help keep stuff in solution so that you can flush it out during your regular flushing as well.
El ácido no solamente ayuda a que no se precipite en la línea, pero no se precipite en el campo. Y mantiene esos carbonatos en solución para que salgan, para que no se taponen los goteros.
Is a question? Saying what pH?
Yeah.
So she was asking what pH is kind of the optimal. That's going to be all over I wouldn't say it's all over the map, but the optimum for kind of what the plant uptake and nutrient uptake is going to be right around 6.5 to 7, and that range is what they were looking for. Typically, these things are going to monitoring pH as well. I don't see the monitor on this one, but they will be monitoring pH and dosing in the acid to maintain that pH is the intent of that system.
Okay, la pregunta es qué tipo de pH se está poniendo en el sistema con el ácido entre 6 y 7. La cantidad de ácido depende de cuál es el pH del agua originalmente. Entonces, la cajita de esa naranja tiene la bomba que está bombeando el ácido en el sistema de riego. Algunos sistemas de bombeo de ácido tienen una maquinita que está midiendo el pH y así se controla. En este caso no está un medidor de pH que veamos.
Now, something that I'm looking for when I come out to evaluate your system is where is that acid being injected? Where are fertilizers being injected into the system? So this one is actually it's being dosed through that pump there, and then as Craig follows, it's coming and entering at the discharge at the filter. Careful. So ideally, the ITRC, you're going to get dinged if that injection point is not before the filter. So we want to see things being injected before filters so that everything is clean when it's entering your system.
La idea, lo importante durante la evaluación es saber dónde está el ácido inyectado. En este caso, el ácido está inyectado después de los filtros. Y en verdad, lo que nosotros queremos es que la inyección sea antes de los filtros para que cualquier cosa que se precipite se queda en los filtros y no llega a los goteros.
So are a lot of you guys using sulfur? Yeah. And there's other options for keeping those lines clean as well. Chlorine, hydrogen peroxide. There's a number of different options out there. So just doing something to maintain lines and keeping emitters clean is a good step.
Okay, I have a question. How many of you injecting after the filter? Okay. How about before the filters? Nobody before the filters, huh? Are you sure? How many do not know where it's injected to? Okay, so that's something to check when, this afternoon on the way into the farm. La pregunta fue que dónde se estaban inyectando el ácido. ¿Ustedes saben dónde se inyecta el ácido? ¿Antes de los filtros o después de los filtros? Después. Después, ok. Todo el mundo dice que después en este grupo. La idea es de mantener los goteros limpios.
Yeah, we know that most guys, or a lot of vineyards, we see things injected after filters. I know that's very, very common. But if you guys are using like an Ag Master solution or something like that to pump into your fertilizers in there, screen mesh filters, screen your solutions and stuff before you're putting them into your tank. It's going to give you that benefit.
Okay, la idea es de las inyecciones. Ok, a ver, los fertilizantes. ¿Dónde inyectan los fertilizantes? ¿Antes o después? Después del filtro. Ay, Dios mío. Ok. Que la idea es mucho más importante el fertilizante. Porque, ¿qué pasa cuando le pones el fertilizante y se mezcla con los carbonatos, se deposita? ¿Ves? Entonces, eso anda, llega al sistema de riego y te taponea los... Gracias. Trabajamos juntos los dos. Okay.
Great.
Yeah.
Okay, so moving on to those filters. Those are definitely those sand media filters in there. Probably more indicative of an older install. You're going to see different types as you go around. But so what kind of types do you guys have? What, if you want to shout them out? Sands. So I see a lot of sand, and the newer types I see are the cleaned tubular screens. So really with that sand media, or the sand, you want to be replacing sand is what you want to do to keep that thing working right.
Que con el sistema de filtración, este es un sistema de filtración con arena. ¿Qué tipo de filtros tienen ustedes? ¿Arena como este? Sí. Nada nuevo como lo de screen. ¿No? ¿Arena todos? No sabes. ¿Screen? ¿Tienes screen? Ah, ¿nuevo? ¿Cuándo lo pusieron?
Hace 5 años.
Hace 5 años, no son tan nuevos entonces. Okay, yeah, 5 years. Okay.
We're just talking about maintaining filters now. So maintaining filters is important. So whatever that is, it's regular. I've talked to guys who do it from anywhere once at the beginning of the season to once a month, taking filters apart and pressure washing them and keeping everything running well. So we're looking at the screen type, not the sand type. So whatever, it's really going to probably depend on your water quality the most. And so depending on your water quality is going to depend on how often and what type of cleaning you're going to need to do to those screens.
Okay, se me olvidó la última parte. Con los que tienen filtro de arena, ¿ustedes le ponen arena? ¿Nunca lo han abierto? Sí. ¿Sí lo abierto? ¿Cuándo lo abriste?
Hace 2 años.
¿Hace 2 años necesitaba arena?
Sí.
Sí. ¿Cuánto lo llenaste hasta arriba?
Solamente se cambia por
Ah.
una nueva.
Se cambia por una nueva. ¿Cada 2 años?
1 año.
Cada año. ¿Y ustedes?
Cómo se va, cómo trabaja.
Con arena.
Sí.
¿Y los otros han abierto los filtros o han puesto más arena? Sí, gracias a Dios. Ok. Entonces, solamente son 2. ¿Lo haces cada año también?
Reviso
Okay, they check the sand filters every 2 years and they add sand to if they need it. ¿Y más nadie? Ok, ustedes los otros saben que los sistemas necesitan arena y la arena se pierde. Entonces hay sistemas de riego que no lo han chequeado jamás en su vida. Significa lo más seguro que no tengan nada de arena. Entonces si no hay arena, no hay filtración. Entonces es una recomendación de que ustedes o digan o chequen la cantidad de arena. How many of the rest of the group check the sand and the sand media filters? Every year? How much?
Every year.
Every year, good. Everybody else? Ever? Never?
Do you totally just replace it or just add to it? Or?
That's depend. We recommend the question if you replace it or add. Some people just replace the whole thing. Some people just add a little bit if they need it. But I think the point is, do you check? Because if you have excess pressure or excess washing pressure, you are losing some of the sand. So you have a sand media filter with no sand. It's doing a great job if you don't have any sand in there. So mainly the idea, if you have not done it, if you don't remember, you probably want to check to be sure that it's something in there. There's always the worry that there's nothing there. And I when I do my irrigation evaluation, I ask the same thing. When was the last time you opened the media filter? And I sometimes get the same answers as you guys said. I don't know. So my report will say, you want to check. And you don't have to open all of them. Just check one of them, because if one is empty, the other one is too. So you don't have to open all of them. It's a lot of work. And please do not open that one while the pump is running. Okay, you want to keep your head, because this system is pressurized, so that'll take your head off, or at least scare the bejesus out of you. Okay, sorry.
We're talking about pressure. We'll talk about pressure now. Yep. That's next. Yep. So, like Craig's saying, the pressure at those filters is another indicator that you might need to be checking your screens or you're cleaning your media a little bit. So the gray box on the end of this sand filter closest to me, that's the backflush detector. It's monitoring pressure for the in and outlets of those filter gauges. It's looking at the differential, and when that differential hits its predefined rate, it's going to give a backflush to that system. So sometimes I don't see those out there, and that's going to ding you. So we want to have an automatic backflush. That's important. And not only that, but making sure that those pressure gauges are working correctly, so that they're actually giving you a correct reading there, and then they're actually backflushing when they're supposed to.
Yeah, that's the other interesting part, that they don't have the automatic backflush, and they don't have any working pressure gauge. So it's always the questions, how often do you backflush? Well, I get all the answers: once a day, once every hour, once at noon. So it's all manual backflushing, but it's not working pressure gauge. So they put pressure gauge probably 10 years ago when they installed the system, and they never replace it. They sometimes don't even have a piece of glass in there. So it's not useful. Ustedes necesitan saber cuántas veces ustedes lavan los filtros. ¿Lo hacen manual? ¿Lo hacen automático? Dependiendo de la presión. O dependiendo de tiempo. El tiempo, ¿ok? Cada 2 horas, 3 horas. 2 veces al día. Cada 4 horas entonces. Ok. Cada 3 horas, okay? Some are set by time, so some of these ones are done every 4 hours, every 3 hours. ¿Ustedes saben qué presión tienen antes y después?
Se sube antes, tiene la cantidad y después sube un poco más.
Ok, pero no saben qué la lectura son. Ok, no saben qué es la diferencia de presión.
Sí, como está
está como a 10 cuando está alto y cuando lava queda como 8, baja.
Baja un poco. Okay. They say that they watch when the pressure differential is around 10, and then of course after they clean up it gets lower. Okay. Again, both are manuals. Nothing are looking at the pressure difference to tell the system to flush. ¿Que alguna otra forma de lavar? Ustedes no lo lavan nunca.
También,
A ver,
es manual también.
manual, ¿cuántas veces?
Dependiendo cómo está el pozo también de sucio, el agua que sale también.
Ah, okay. They look at the water, see how dirty it is to see how much they need to flush. Okay. Pero los relojes funcionan.
Sí.
Marcan el mismo, sin presión o no presión. Tienen que marcar, okay.
So moving on from the filters, the next thing that we're going to be looking for is, do you have a flow meter? And the answer over here is yes. They got the digital, beautiful AG2000. It's hooked up with telemetry. So when you have a flow meter, something you got to do is record every day how much water did I apply. This guy's doing it for you with telemetry, straight to his cell phone, straight to his computer. Some of you guys might be writing it down still.
Okay, I'm going to ask the questions again. Looks like I'm the only one asking questions. That all of you have a flow meter. ¿Tienen un caudalímetro para medir la cantidad de agua? El grupo esto trabaja muy bien. El grupo de acá no sé qué es lo que está pasando. Okay. El caudalímetro es muy importante porque dice cuánta agua estás utilizando. ¿Ustedes escriben cuánta agua utilizan al día? ¿Sí? No, ok. ¿Ustedes ven el caudalímetro cuando están corriendo? Dice cuántos galones por minuto. ¿Ustedes lo ven? Por lo menos está funcionando.
Sí.
Ok. A ver, por allá. Did you guys look at the flow meter when it's working? You guys back there, do you look at the flow meter? Yes?
So basically, from that point on, we're heading out to the field. After that, there's a couple little gates and different ways to open up. But the main thing here is that we want to have working pressure gauges, working flow meters, so that we're able to actually take observations and see what's happening when we turn on the pump before we head out to the field or after the water's been running for an hour or two.
Okay, es importante que todos los medidores de presión, todos los relojes estén funcionando, todas las válvulas estén abiertas. Bien, con el VFD podemos dejar las válvulas completamente abiertas. No hay que controlar, cerrar o abrir, que en otros lugares no hay. ¿Alguna pregunta de qué es lo que hay aquí que ustedes no saben qué es lo que es? ¿Todos lo conocen? ¿Todas las partes que hemos hablado? No me pregunten a mí porque yo tampoco sé. No. Yeah, dígame. Uh-oh.
I have a question. So he said that the pressure gauges were reading exactly the same before and after the filter. So would that raise a question in your mind? I mean, wouldn't you expect a differential?
Yes.
Yeah.
Yeah, but not each pressure gauge is going to read exactly the same number.
Okay.
So it's always an error, a variability. So it's probably 1 or 2 psi, depending on the pressure gauge. If the pressure gauge is 100 and you're reading 10 on 20, you know that is a big error on that 10 to 20. So if you're going to be reading around 10 to 20, you probably want a 60 psi pressure gauge. So it's reading in the middle. So that will be the least error that you have. So yeah, it's strange, but I need to see if is that a 100 psi pressure gauge?
I think so.
Okay. So yeah, what was the reading? 60?
60.
Yeah, so it probably be 1 or 2 or 3 psi difference between those two pressure gauges.
What would you expect
It's a
across that
160.
filter? Wouldn't you expect like 4 or 5 pounds?
Yeah. That's what that was expect. So I think it's between maybe 5 and wash wash at 10.
Yeah.
Yeah, so that's what I expect. So probably a little bit off. You know, I probably would be a recommendation maybe to check the pressure gauges or replace it depending how old they are. How old they are?
Those are a couple years old.
Yeah, so you know, maybe my recommendations, if I get the same number, I would just put a new set, just to be sure that is reading correctly.
The other way is just put a Schrader valve on there and have one gauge.
Yeah, so that's true. So if one reads, you have two bad readings instead of only one bad reading.
But at least using the same gauge.
That is correct. That is correct. I've seen that a lot, that they use one pressure gauge. Estaba preguntando que la lectura es la misma de 60 antes y después, preguntando si hay algún problema. Y la respuesta fue que posiblemente, porque no dos relojes miden el mismo número, pero uno espera que haya de 3 a 5 cuando están limpios y 10 cuando hay que limpiar. Ok, perfecto. Confirma. He confirmed. Okay.
Watch out about air valves.
Okay. Do you required to install air valves in your system? Is always at the outlet, at the highest point by your filters, so you don't get any entrapped air in your system. So be sure that you have it. Most of the design system will have it. You know, the engineer will put them in there. There's some air release vents also at the is that the inlet, at the outlet. Which way the water is going, to the little one or to the big one?
Right now it's going to the big one.
Oh, it's going to the big one, not to the little one.
Oh, wait, actually it's going to the bowl.
Oh,
Yeah, I got 50 PSI on bowl.
okay. Is that before or after the valve?
After.
Both of them? Okay. Siempre, they always want to have an air vent also, you know, because it had the elbow going down. They want to have an air vent at that point. So by design, highest point, lowest point, anything that that goes down, any of the high points, you need to want air vent to get rid of the air. You don't want any air in the system. Tienen dos sistemas para dos respiradores. Como ven arriba de los filtros, tienen un respirador. Por diseño se recomienda que pongan respiradores en las partes más altas. Y eso es lo ven en la parte de arriba. También cuando tengas un codo, tienen unos respiradores. A veces al final del bloque tienen respiraderos porque hay que evitar que haya aire en la línea. El aire en la línea crea una presión muy excesiva que crea que las pipas se rompan. Entonces por eso se le ponen las respiradores para que el aire salga de las pipas.
Why don't you want air in there? Why not? What's the problem with air?
They produce excess pressure. You know, they compress the pressure in the line, and that the pipes don't like that.
Like a blocker.
That is correct.
Okay, so moving on from the pump station, then we go out to the field, and we are looking at pressures and flow rates in the field, and that's going to give us the rest of the numbers we need to give you a DU number.
Okay, ahora vamos a ir, ya que terminamos con la bomba, vamos a ir al campo a hacer mediciones de volumen, cantidad de agua que sale de los goteros y presión, medidor de presiones en el campo también.
The way that we decide where we're going to take readings is based on the distances from the pump hydraulically. So not like literally walking out there, but where are the main lines going, where are the manifolds, and how is the water being distributed throughout the field.
Okay, ¿dónde decidimos a dónde vamos a medir los volúmenes y las presiones? Depende de la distancia hidráulica de los lugares. Se buscan lugares que estén cerca de la bomba hidráulicamente, que es lugares que están más lejos de la bomba y lugares que sean en promedio, para que nos den una idea de presiones altas, bajas y medias.
So then those readings are taken at locations close to the pump, middle, far. Did you already go over that?
Yeah.
And then we're going on the individual row itself. We're also going to hit at the uphill section. We're going to hit the riser. We're going to hit in between each of those, and then we're going to hit the most downhill part of that, so the furthest from that riser as well.
That's pressure measurements.
Pressure measurements, yeah.
Vamos a medir la presión en la cabecera del bloque, donde está la válvula, donde se abre y se cierra. Vamos a medir en la parte más altas, vamos a medir en el medio y vamos a medir al final. Estamos buscando presiones muy altas y presiones muy bajas. Eso es lo que estamos buscando, midiendo presiones al comienzo, al final, en la mitad.
I do the same thing with flow rates. So I put a bucket underneath the emitters. I capture water, and we do that close to the pump, middle, and then again far from the pump. So we want to arrange and see how that system's performing over different variability there.
Además de medir la presión, estamos midiendo la cantidad de agua que sale. Vamos a poner los potecitos estos transparentes que tenemos aquí en lugares cerca de la bomba, en la mitad y al final o lo más distante de la bomba.
So if you guys want to kind of gather around this area here, what we'll do is I can kind of walk you through a little bit, take a pressure measurement, show you what that looks like, show you the tools that I use, show you a little bit of the water. We'll pop in a new emitter, show you the difference between old and new, and we'll just kind of walk it through a little bit. So when I go out in the field, this is what I need to get your guys' uniformity. So the main things I'm going to be using is just a simple little punch a hole in there. We got two different pressure gauges, a 0 to 60 and a 0 to 100. It's just depending on what I need, and I got some backups in the truck in case those break. Goof plugs, lots and lots of goof plugs. Extra emitters, because you need to pop these out. And I break them apart. I got a bag of old emitters here, so you guys want to break these apart and see what's in them, you certainly can. This is how we got to put that goof plug in there. So you need dikes or grips. Stopwatch for the test. So all together, this stuff like less than 20 or 30 bucks. And it's everything I need to evaluate and get the job done. So I picked this area here. I don't know if you want to talk, but
that's okay. I think
they got the idea, yeah. So I picked this area here because there's just a couple of 1 gallon per hour emitters. This one here, you can see, he's got a little bit of spray to it, so it's kind of might be broken. This guy's here might be what a lot of us would consider a normal, good emitter. So what I'm going to do is I'm going to punch in a brand new 1 gallon emitter right there so we can see what an old one looks like compared to a new one. You guys might want to...
Como ven, ahí él va a medir, como ven, uno de los goteros está poniendo mucho más agua que el otro gotero. Significa que hay por lo más seguro que tenga ya está muy viejo, ya no controla la presión. Entonces él va a ir allá a poner un gotero más para determinar la presión. Are you going to measure the pressure?
Yeah, let me do that first. So here's my tube, here's my pitot tube. So taking a pressure is as simple as making a hole here.
Okay, he just punch a hole.
Now I want this tube to face away from the direction of the water. What I did not do was I did not take this emitter out and use the same hole. I punched a brand new hole. I've seen a lot of irrigators, they pull this out and they'll just slip the emitter back in. There's a hole around there, you're not going to get the real pressure reading because there's going to be air leakage and water leakage around that. This is a tight fit.
Sí, como ven, algunos regadores miden, sacan los goteros y ponen el pitot tube para medir la presión, pero el hueco es mucho más grande que el pitot tube. Entonces es mucho mejor abrir un hueco nuevo, poner el pitot tube para medir la presión y el tubito tiene que estar apuntando en dirección contraria a donde viene el agua. El agua viene para allá arriba, lo tienes que poner apuntando para abajo. Okay?
So in case anyone's wondering, the downhill pressure here is 37 on this line.
The pressure is 37, la presión es 37.
Now I'm going to pop in a new one. You can compare it to this one.
que él va a poner uno nuevo para comparar la cantidad de agua y como ven, el nuevo parece que está poniendo más o menos agua. Más parece, ¿verdad? La gota. Okay, I think the new one is putting a lot more water than the old one there.
It should be pretty visible, but we can also measure that.
Okay.
So we can take a quick little reading here and see how much is this recording. So I'm going to let my stopwatch run. The way that I do it is I set them down every 5 seconds. We'll let it run while we talk a little bit longer, and then we'll measure it at the end.
Okay. Él va a poner los botecitos y va a medir el caudal para ver si hay alguna diferencia entre los dos viejos y el uno nuevo que él acaba de poner. La mayoría, él pone, how many you put, 12 or?
At the downhill, the farthest, we would do 28,
Okay.
16 to 28.
Okay, se ponen de 16 a 28 botecitos para medir la uniformidad del riego.
And so while we're letting this guy run, what we'll do is we're just going to go ahead and do a flush out at this last line here. So that's another important thing that we do is when we flush, we're not just going to let that little shoot out until the water runs clean after a couple seconds. It's letting that water run for a long time at a high pressure so that turbulence and velocity breaks up any of that precipitate, scale, and all that stuff gets loose and actually out of the system. So it's not a couple second flush, it's a 10-minute flush.
Okay, ahora va a limpiar, va a abrir al final de la línea para determinar cuánta basura se acumula. Es un indicador de qué tan limpio es el sistema. Y la idea no solamente de abrirlo por un minuto, es de abrirlo por 5 a 10 minutos para que toda la basura salga, que es el indicador.
18 to 26 or so.
Okay. ¿Alguna pregunta? Any questions so far?
So what I do is I have a little nylon sock. I'll put that on the end of the hose and I'll catch what comes out of the line.
Okay.
See what's in there.
Va a poner la media esa para colectar a ver qué sale. You need to remember to hit the end so you don't catch a bunch of stuff that is growing in the outside. You really want to know what is inside the line. Okay.
So
It's clean.
pretty clean, but we'll see what's in there after letting it. I'm not going to do 10 minutes, but I'll let it run for a good minute, 30 seconds to a minute, see what I collect.
Okay, it looks pretty clean. It's going to still let it run for a few. It's not going to wait 10 minutes, but it's going to be sure that it gets everything that is going to come out. It's going to come out, so it's waiting for a little bit. Lo va a dejar, no lo va a llevar por 10 minutos, pero lo va a hacer por un par de minutos para ver si algo sale. Como ven, está bastante limpio. Así se ven los de ustedes allá, limpiecito.
No, porque nosotros es muy diferente para allá.
O es leche de chocolate cuando sale.
Sí, casi como...
How long did you flush it for?
This one is probably
3 minutes?
3 or 4 minutes. We had two guys, one guy walking ahead, opening, and the guy walking behind.
Okay, so he asked me a question, so I'm just going to ask you guys, how do you keep it from not flooding the road?
You don't. All right, there you go.
Okay. So that means you have a good infiltration in your soil, so you don't get that much.
No, it's just part of the deal.
Oh.
I don't know.
Okay. Okay, anybody else flush their systems?
A little bit. Sand.
Okay. No problems flooding the roads?
Yep, sand.
Getting stuck?
So even though it's clean, there's still a little bit of sand that came through there. You don't see that in the water, but there's still a little bit that got caught in there.
Todavía hay un
So
poquito de
there's stuff
arena.
that gets in there.
No mucho, se ve muy bien. Pasa el examen.
Okay. So it's been about 4.5 minutes. We'll go ahead and see what we got.
Ok, 4 minutos y medio. Comparar el nuevo con el... Miren la diferencia entre esos dos y el primero que estaba botando más agua.
Okay, so this one was here.
Jacob, take that one first.
I forgot that one.
Oh, that's okay.
Should have went that. Didn't see that there. I'll forget that one.
No, that's
the
important
broken
one.
one, yeah.
That's we'll subtract a couple of mils.
I don't think that'll even work with that.
Okay, so he's gonna do some volume measurements on a very scientific graduated cylinder.
Over 250.
Okay. So we're trying to compare between the two flows. Oh, that's
A
pretty
little more
good.
there.
So far, so good.
I don't have the same size. Now we're
What
gonna
is it?
get screwed up. So let me go on my truck.
Oh, the question is, where do I get a graduated cylinder? You can order it in the beautiful Amazon, and then deliver overnight if you are Prime. Okay, that's the easy way to go for. I don't know if it's any local ag store that have graduated cylinders. Any of the wine labs, okay.
They're pretty close. Pretty close.
Okay.
Yeah, they're all about. So this one I can measure. I mean, we could actually do measurements. But this broken one's definitely more.
Okay, the broken one is going to be the champion. We are not going for who can put more
this
water in the system. Okay, that's not the objective over here.
So I mean, they are all pretty darn close. I mean, we did pretty. These two that we didn't touch. This guy's probably by, say, 260 or so.
260 on the first one.
This guy is very similar, a little bit more, probably like 265, 270.
270.
This one I could get a good reading on. So this is the one, brand new one that is working. It is at
The brand new one.
285.
285.
It's a little more.
That's not bad. That's not bad.
And then that guy at the end was 540.
540, the winner.
So that's 500 milliliters versus 200 milliliters in just this section here. You know, so that little section compared to what's going on, multiply that by the whole set, that adds up real quick. And this is just 4 minutes. You know, that's not 4 hours or 8 hours.
So the point is that you get 500 in one and 200 in the other ones, and that's only a 4-minute reading. So when you're looking at a 4 hours irrigation or 8 hours irrigation, you're looking at a lot of water, twice as much put from one emitter than the other. So it's very important to distinguish, and that will affect your DU too. Acuérdense que hay una diferencia entre 200 mililitros y 500 mililitros, y eso solamente fue en 4 minutos. Imagínense en un riego que son de 4 horas, de 8 horas, de 10 horas, la cantidad, esta planta recibe 2 veces más agua que la otra planta. Okay, eso terminamos lo que teníamos para presentación. Si tienen alguna pregunta, alguna observación, algo que les interesa o les preocupa con respecto al riego, vamos a estar aquí. Just ask anything. We don't get paid by the hour, guys, so we are here for the rest of the morning. Thank you very much for coming.